It's a series or a list of variables in the computer memory. It's all variables share the same name and must be on the same data type. Each variable has a different subscript or index here. Sometimes I call it the index because I think the index makes more sense to me. But of course, the subscript or the index is the same. So now come back to the example, right? So come back to the example when working the loop. Now and think about this one here. Think about the loop, right? So one thing about the loop here, so think about you have to write the program to ask user to enter grade for the 10 student here or 10 student, right? So normally you have the counter. You think about the have a counter here. And at the beginning you set the counter number 1, right? So now we have the loop, you have the counter. Yeah. In the case the counter is less than or equal to 10. You keep doing it, right? Keep doing it, right? So you get the input from the user here, and the input, right? You have enter, great, right? So you keep doing it, and in the case, and every time, of course, every time you have to increase the counter here. Counter equal to counter plus 1, right? Counter equal to counter plus 1 here, and you go back to the loop. And you go back to the loop here. And again, just enter grade here. You do it for 10 times. Alright, so think about this one here. When you've done everything with the 10 times, you can maintain about the loop. You remember that in the case you work with the loop, you have the two most common applications when working the loop. The first one is to figure out what is the total, what is the sum here. Right? And the second one, figure out what's the average here. And in order to do that, you don't know that. In order to figure out the total, the sum, you only have to maintain the accumulator here. And remember that in order to do that, you have to set the sum here equal to 0 at the beginning. Remember that. You have to put the sum, and every time if the end user enter grade and you figure out the sum here, the new sum equal to the old sum plus the grade here. The grade is the user enter here. So think about at the beginning you have the sum 0, right? Now if he enters the number 10, you have the sum number 10. Now if he enters the number 30, you have the 40 in the sum, and so on. It is the accumulator here. Now think about this one. Everything works perfectly, right? Everything works perfectly for this one. Now think about this one. When we're done with the program here, when we're done with figured out the total grade of the 10 student here. Now I want to raise a question here. I want to add you I want to add you to modify the program. So I want to check what is the grade for the student number 4. So how can you do it? When you've done everything with the total here, what is the grade of the student number 4? How can you do it? How can you do it? You just enter the 10 grade for the 10 student here. And you figure out the sum and print out the sum, everything works perfectly. But now I want you to print out the grade for the student number 4. How can you do it? How can you do it? How can you do it? You cannot do it. Why? Why you cannot do it? The question here, why you cannot do it? Think about this one. Think about it. You add the grade here. Grade here is a variable, right? Grade is a variable here. So think about this one. You have variable here. Now, you enter the number 10 for the first student, right? And you figure out the sum now is the 10, right? Now, for the second student, you enter the number 40 here. So see, when you enter the number 40, you override the last student score here. You have no more 10 here in the same memory. Right? See, for this one, you have no way to look it back the grade for the student number 1, number 2, number 3, number 4. Because every time the number 10 here is the last one, it overrides every score of every previous student. You got it or not?
Yeah.
The thing is that you only have one variable here. It is grade. So every time you enter the new grade, it will override the old grade here. So we see for this one, you have no way to print out what is the score for the student number 4 or number 5 or number 6. You have no way. So you can modify the program here. You can so you have the enter a grade for student number 1. So we put it in the grade one here. It's a one variable. It's a one slot. It's a name grade 1, and enter the grade for the student number 2. You put it in the grade 2 here. But for this one, you cannot do with the loop here. You have to do it in the sequence. You have to enter the grade number 1 and grade number 2 and number 10 and so on. You have to do it in the sequence. You have no way to working with the loop here. So we see that is a huge problem when working the loop here. So in order to overcome this one, there is the array here. The array is a list of variables in the computer memory. So instead of store everything inside the same memory, now it breaks it down into continuous memory here. So this one, it is index number 1 to the score of the student number 1, and index number 2 to store the grade of the number of the student number 2, and the 3 here to the store the grade number student number 3 here, and so on. So we see the theory is a list of variables in the computer memory, and all variables share the same name. So think about this one. You put the grade here. You put the grade. All of them have the same name. But for the first student, I have the number 0, index number 0. That means the first student. And for the fourth student here, I have a grade number 3. That is the fourth student. It's a grade of fourth student. You see, they have the same name here. They have the same name here. The only difference is the index or number array or subscript of them. Remember, when working with normally when working the order of the programming language, the index number is number 0 here, and the next one is number 1 and number 2 and so on. So we see they have the same name. They share the same name here, and it must be the same data type. So all of them must be the same. So they must be on the number for the grade here, the number format here. Think about that, right? And each variable here have different index or subscript here. So the first one is number 0, and now number 1 and number 2 and number 3 here. All right, so see, all of them they share the same name, but they separate each other by the index number. So we see when you enter the grade for the order of the 10 student, everything from 0 to 9 here. So next time, if you want to come back to look it up, what is the grade for the student number 4? It's very easy for you to look it up. You look it up, you know that this one is grade, and the index here is index number 3. That's all. That is the benefit of the array here, because you see they share the same name. Share the same name, and each variable has a different index here. It's not override each other, and they are on continuous. They are on continuous memory slot. And one more thing about array here, you can use the loop here. So for the 10 student, use that enter grade, and you change the index number here. You can do you working with the loop very useful when working with array. Okay, so how array occupies the computer memory? Now you have some definition. Element is an item in the array. An array element are continuous in the memory. And the size of array is how many elements it is. So think about, come back to the last example here. You have array here, the name is grade here. Grade, and you have 0, and you have 1, all over to the 9 here. For this one, so you have the 10 elements. For this array, you have the 10 elements, right? And array element as a continuous memory, and the size of array, that means how many elements the array has. For this one, you have the 10 element here. Everything from 0 to 9, you have 10 elements. And you have the subscript or index, they are the same. It's a position number in an item in array starting from 0 to 1 less than the number of elements. You see, for this one, you have for this one you have 10 elements, and starting from 0 and go to the 9, 1 less than 10 here. Right? That's why you see 1 less than the number of elements in the array. But remember, that's starting from 0. That's why the all over to the 1 less than the number of the element in the array here. Right? And adding data value is called populating the array. So if you want to get the input, you can go to populating array. Right. That is the how array occupies the computer. They just store it in the continuous memory continuous slot in the memory. Okay, now we have the characteristic of array. An array is a list of data item in continuous memory location. Each data in an array is element. And each array element is the same data type and the same size. Each element is different from the other by the index here, by the index here. And usable index for the array, everything from 0 all over to the one less than the number of elements here. And each array element can be used in the same way as a single item of the same data type. Now, so the question here is how array can replace a netted decision. It's very, very useful when looking at the array here. You can replace a netted decision. Right. So example here, you have the human resource department. You have to do the dependent report here. You have the list employee who have the claim 0 to 5 dependent. You see, you have everything from the 0 to 5 here. From 0 to 5 dependent. So whenever and you have to maintain the counter. You have to maintain the counter. So at the end of the process, you have to tell how many employees have the 1, how many employees have the 0 dependent, how many employees have the 1 dependent, and how many employees have the 5 dependent. Right? That's the same here. So the application produces a count for dependent categories. It have the normally you have to work in decision here, right? You break it down in decision. If dependent 0, increase the counter. You have to maintain the 5 counter here, right? If you don't working with array, you have to maintain 5 separate counter here. I can think about this one. You can think as a count. You can think about this one here. Count 1. Sorry, count 0 here. Right? Count 0 here, and I maintain another one. We have the count 1 and count 2, count 3, and count 5 here. So in that one, you have to maintain 5 separate counter, and you have to work in decision. You check if the number of the dependent 0, you increase the counter 1. You increase the counter 0 to 1, and if the number of dependent is 4, you increase the counter 4 to the 1 here. So normally that you're working with the selection here. Here, you can think about this one. You can think about this one here. You have to maintain the 5 separate counter. Count 0, count 1, count 2, count 3, count 4, and count 5 here. And you check in netted decision here, right? So see, if 0, increase it. If not 0, it can be the 1, increase 1. If 2, increase 2, 3, 4, and 5 here. You see, you have to break it down in the netted decision here. In the netted decision here, right? Now, think about this, how to overcome it here. How can array can replace a netted decision? Array can reduce the number of statement needed. 6 dependent, everything from 0 to 5, and count accumulator are replied as a single array. So now instead of maintain the 5 separate counter, you need 1 array name here. You have the count here. You maintain the 1 array name. You have the count. You have a count, and of course, in the count here, for this count, you have the 6 element. A 6 element, and the index of element is the 0. Come all over to the 4 here, right? 1, 0, 1, 2, 3, 4. That you have 5 elements. So this one you have to maintain the variable name is the count, and the size of this one is the 5 element. You have everything from 0 to 4. And array subscript variable must be numeric and no decimal place, initialized to 0, and increment by 1 each time the logic passes the loop here. Now, see how it works in this one. Okay, now think about this one. Okay, so now we see instead of maintain the 5 separate variable, count 0, count 1, count 2, count 3, count 4, and count 5. Oh, you have already count 5. So we have the 6 element. right? So for this one, you see, instead of maintain the six separate counter, you have the count 0, you have count 1, and all over to count back here. Now you can store it into the same, right? You could store it in the same variable name here. It is array name count, and you just separate each other by the index number here. You have number 0, number 1, number 2, number 3, number 4, and number 5. But again, if you look on the previous program, you see no improvement here. You still have working a lot with the method decision here. Not good at all. It's not good at all. Actually, I don't see any improvement here. Right? So this one is, please do not working with this one here. Now, how you can overcome it here? Now, next slide you can see. This one also is not work, right? See, now you check dependent here. If dependent 0, you change it to depth here. Instead of 0, you change it to depth. Also, depth 0, yes, that's why it's the same with 0 here. This one was the same with 1 and 2 and 3 and 4 and 5 here. Again, no improvement for this one. Huh? I don't see any improvement for this one. Now, come back. Move forward here. You can see what is the improvement here. Now, see. That is the improvement here. Now, instead of working with the selected decision, you can see right now it's way better. Right? So see, you always have the number dependent. You only have a number independent from 0 all over to 5 here. All right? All over to 5 here. So it's called, it's a depth here. So depth here can be 0, 1, 2, 3, 4, and 5 only. Right? So now see, you have the variable name here, num count. That is variable name. And for this one, you have the 6th element, and you initialize the 6th element at the beginning, order of 0 here, right? Order of 0 here. So now we just do it here. If the number, right? If the end user enters the number 3, if the end user enters the number 3, that means the dependent number 3. So what will happen here? So you maintain the count. The depth here is the depth number 3. The depth number 3, and you increase the depth number 3 to 1 here. That's all. It makes it simple, right? You don't have to work with the selected decision anymore. It's work way better here. You got it?
Yeah.
No? Okay, so you see, it totally depends on the depth here, right? You see, now if you depth number 4, increase the counter number 4. If the depth is number 5, increase the counter number 5 here. That's all. It's very simple. Okay, so now we look on this one in the flow chart here. Right? Again, you have the housekeeping, you have the body loop, and you have finish here. You break it down, right? So housekeeping here is a get ready. So what? Sorry, what is get ready? In the get ready, user enter dependent or quit to quit here. That is a sentinel control, right? Remember that in the loop you have 2 types of loop. The first one is definite loop. I mean, you know for sure how many times you do here by maintain the counter. The second one is controlled by indefinite loop. You have to maintain the sentinel here. So think about if you want to continue or not, or enter negative number to exit, or enter n for exit here. That is sentinel control here. Right? So for this one here is controlled by the keep doing it, and whenever the enter the quit here, it exit it here. So every time you input the dependent here. So every time you input the dependent here, now if you doing it, the counter dependent. So what is the counter dependent? You just see you only have one option here. Sorry, you only have one action here. Instead of breaking into the selection, you see, you just increase the counter and depth here to number 1. That's all. So if you enter the number 0, you have the counters. You have the counter index 0 increased by 1. If you enter the number 5, you have the counter index number 5 increased by 1. That's all. And again, if you want to continue or not, let's do it here. And at the end of that, you have finished here. You just print it out, right? Dependent count here. Okay. Okay. So now, if this is a work, when working with the with the pseudocode here. You see, you have declaration for the number of dependent here. You initialize the array. Right? This one you have the 6 element here. Right? You have a 6 element, so we put this one, everything 0 here. And the quiz is 99 here. Now get ready. Keep doing it here. Right? Keep doing it here. Keep doing it here. And now why you have why not quick counter dependent here. See, it depends on how many dependent you enter. So we just increase by the counter here. Right? And you just keep doing it and finish here. Output dependent. So the last step here you just print out. The last step here is just print out what is the value for each counter here, for each counter. So it can tell you what if the 0 dependent how many, and 1 dependent how many, and 3 dependent how many. That's why it's starting from 0 here, right? On over to the 5, 0, 1, 2, 3, 4, 5, and every time you have to print out the value of the array here. You see, you have to count the value here. Count here is array name, and depth here it is the index. So we have everything from index number 0 on over to the index number 5. It's just print it back here. Okay. And one more thing about this one here. When you work in Raptor, a little bit different. You have to pay attention when you work in Raptor. Raptor normally for every programming language, the first index is index number 0. But when you work in Raptor, the first index is index number 1. That's why a little bit different, and you have to change it here. You have to pay attention on that. Now you can work this one. You can work with this one with Raptor also. You can see how it works with Raptor here. So in the Raptor, you have what is it? You have the what's the name of the counter? Calf is the type calf here, right? It's 16, and it says 0. So it's at the beginning, it says the size of the array here, the 6, and all of them 0 here. So use that, and you have the input here. That is housekeeping here, right? So and something like that, right? And the -1 to exit. I use the Sentinel control here, right? So this one is a pen, a dependent, right? What's the name of this one? Sorry, this one back. Dependent. Now you just maintain the loop, right? You just maintain the loop here. So what do you think? What is the condition here to exit the loop? What is the condition here to exit the loop? If you look at the Raptor here, what do you think? What is the condition to exit the loop? Huh? What's the condition to exit the loop?
To exit the loop?
Sorry?
You said to exit to the loop, or?
Exit the loop. Yeah, what's the condition to exit the loop here? What do you have to put in here? Right. It already tell you where, right? It already tell you enter the number dependent from 0 to 5. So if everything from 0 to 5, keep doing it, and enter -1 to exit. That it tell you already. So we have to be consistent with this one. So whenever you have that equal to the -1, you exit it. That's all. Make sense? Yeah, that's right. So now see what you have to do here. When you enter the lab, is 0, what you have to do? And when the depth is number 1, what you have to do? If you look on this one here, see, it depends, right? You have to count depth here equal to count depth plus 1, right? So we just modify here. You have the assignment. Now, remember that I mentioned to you that when working the raptor, you have started the index number from the number 1, not number 0, right? So in order to do that, I had to put the number plus 1 here. Plus 1, you have to add in one more one here. You cannot starting from 0, otherwise you got the syntax error in the raptor here. Right? So now got one. And again, you check it again. You want to continue on or not? And look to run it to see it work or not. What is it? Oh, sorry, I made the mistake here. What is it? Why not run? Right. So now think about I input the number 3. Sorry, you have to put the count as here. Inconsistent name here. You put the count as. Okay, now run it. Number 3. Number 4. Number 2. Number 1. Number 4 again. Number 2 again. Now -1. Now you can see. You can look on the count here. You can click on this one. You see? Now you see for the 0 you have no 1. For the 1 dependent you have 1. For the 3 dependent you have 2 here. Right? For 4 dependent you have 1. Or this one why you have? Oh yeah, sorry. So number 1 here that means 0 dependent. Number 2 here that means 1 dependent. Number 3 here, that's the sign, right? Remember for the index interrupter, you have to decrease by 1. That's the one. And you see it already stored over there here. Now, if you want to print it out, right? If you want to print it out, how many dependent of the 0? How many dependent of 1? Of the 2 and the 3? You just maintain under the loop here. You have the loop. You have the under loop, and of course for the counter, you have to maintain the counter here. We set it to 1. And what do you think? What is the condition here to exit the loop? What is the condition here to exit the loop? You want to print out every element in the loop, in the array here, and you're starting from the element number 0, but in the after is the number 1 here. So what do you think? What's the condition to exit the loop here? What is the condition to exit the loop? What's the condition to exit the loop? Any idea? What's the condition to exit the loop? Now you see, you have for this one you have the 6 element. You have the 6 element here, right? So is that the condition here? That's the when you have a counter here. Greater than 6. Right? Sorry, greater than 6. Exit 0. So in the case the node, you just print out, right? You want to print out. You want to print out every element of the loop of the array. Sorry, you just have here. You have count S and you have the counter here. That's all. That is the pre-now here, right? Or to make it better, okay, it's this one. Okay. Now think about this one here. Right? Now I have the 0 dependent, 1 0 dependent. I have 1 dependent. I have I have a 1 2 dependent. I have a 1 3 dependent. I have 1 4 dependent. I have 1 4 5 dependent. Now I want have 1 more 4 dependent. Now I exit it. Yes, I'm going to go here. Why I make mistake here? That time. Oh, sorry. One more thing about this one. What's wrong here? What wrong? What do you think? What's wrong with this one? Why keep running forever? What do you think? Why keep running forever here? Yeah, right. Because it's always number 1. That is infinite loop here. So we have put it. You have the counter equal to the counter plus 1 for this one. So think again, I put number 1, 2, 3, 4, 5, 0, and number 2 again, one more. Now I see it. Okay, so you can see now, you can see for now, I have 1 dependent with 0, 2 dependent with 1, 2 with 2 dependent, 1 with 3 dependent, 1 with 4 dependent, and 1 with 5 dependent here. And you can see it print now here, print out exactly here, right? 1 0, 1 1, 2 2, 3 1 3, 1 4, and 1 5 here. Yeah, make sense? Hello?
Yeah.
You see, user do all the one step here. Instead of breaking down in the method selection, right? Check if it's 1 increased by the counter 1, check if it's 2 increased by counter 2. Now we insert only 1 step here. It's way, way better working with array. Come on. So using the constant with arrays, use the constant in several ways to hold the size of an array. The array's value as an index here. Using a constant that has the size of arrays. Remember, try to avoid the magic number. The magic number is an unnamed constant. So we see that try to avoid it and declare the name numeric constant to be used every time the array is accessed. Make sure that any index remains less than the constant value, and constant creates automatic in many language. Sometimes the value stored in array should be constant. You think about this one. Yeah, 12 months. That's why I put the number 12 here. And using the constant as the array subscription. So instead of the define for the arrays or for arrays with name sales array, and you have the price index. You put the number in here, the 5 here, and you put the price. Try to avoid the magic number. Searching for array exact match. Sometimes you must research through an entire array to find the value for linear search. Example, you have the mail order business item number at the 3-digit and non-consecutive number. A customer order an item, and you have to check if the item number is valid or not, and create an array that holds the valid item number and search array for exact match. And in order to search here, normally you have to maintain the black. So normally at the beginning you have to set the black in the full or no here. So whenever you search something in match, you change the black to the true or yes here. So in order to working with the searching array, you always have to search from the beginning. That's why you have to set the index variable to number 0. That means you want to start from the first element of the array here. And the second one, you have to initialize the black variable to the 4, right? To indicate that at the beginning you have not found it yet. So whenever you found it match, you change it to the true here. The exempt each element in the array. So we starting from the first element, move to the second, move to the third and the fourth, and so on until you find the match here. Right? If the value match, set the black to the true. If the value doesn't match, increase the index until the end of the last element here. Okay, so now think about this one here. That example here, right? You have the valid item, and you have the valid item with a number here: 106, 108, 307, 405, 457, and 688 here. They are the valid item. So now every time the customer enters the item number here, every time the customer enters the item, you have to look it up if item matching with any element on this one here, and every time it match, every time it's matched, what do you do? Sorry, this one here. Every time it match, put it found it here. I found it. That's all. So now see. You see, you have the 106, 108 here. All of them are valid item. And now you get the input item from the end user here. Now, when you got the input item here, you have to check it. You check it here. Of course, when you finish, you exit loop. So you check with the file item. So what is the file item? Okay, you see, you have something you have to remember here. Set the index variable to 0 at the beginning. Set it to the 0 at the beginning. The second one, you have to set the flag here to the 4 at the beginning. Okay, you set the 4 here, the no here. All right, no at the beginning. Now you're starting from the 0, and you run all over to the side. What is the size here? You have 1, 2, 3, 4, 5, 6. You have the 6 element for this one. That's why you have the size here. Now every time you check it, each item equal to the valid item of the index here. Yes, you change it black here. You see, at the beginning you put the no. Now you change the black to the yes. And you move to the next one here. You move to the next one and do it here. Now you can think about this one, the process here. You have the process. You have the process here. So you have the 4 number. You have the some number here. You have 404, 408, and so on. Yeah, so think about 500 here. So see, at the beginning you set the index number 0, starting from this one. You set the starting index number 0, and you set the flag here. You set the flag is no. At the beginning you have not found it yet. Right? So see, you run everything from 104, 108. So every time you have to check here. If the item equal to the 104, you found it, change to yes. If not, increase by 1, move to the next item. I check again. If the item equal to 408, if it's match, you found it, right? And increase here until the end, until the end of the loop here, until the end of the last element here. And of course, you have In the case you exit the loop, you have the two positions. You have the two possibility here. The first one, you run all over the you run all over the element of the array, but you are not found it. But you not found it. That so in that case here, you put here output message no, and you set bad item here. You increase this is the bad item, right? And output here. And in the case matching here, you set output the message here. Okay. You got it or not? Remember for this one, you got it or not? You got the logic here or not?
Yeah.
Yeah. Right? So every time you got the item and you just check it to every single element in array, you see it match or not. If it match, you just change the blank here. And you see when you run from the first element until the last element, you have to exit the loop. And in the case you exit the loop, you have two possibilities here. The first one, you not found it. Right? In this case, you not found it. You put the bad item here, includes the bad item plus one, increase it by one. Otherwise, you just output here, message if that means I found it here. Right? Okay, now, what do you think about this one? Any idea? If you look on this kind of searching here, what do you think? Anything you can, any idea you can think that you can improve the searching here? What do you think? Now, think about this one. Now, okay, the question again. Any idea you think that you should apply to improve the searching process? What do you think? What do you think? What do you think? Now think about this one. Think about you have the list of the valid number. You have 1,000 valid number. You have 1,000 valid. Now think about this one. When you run to the 104 or 101, far away here, you found it match. Alright, so we think about this one. In the case you found it match, you should exit the loop. You don't have to run it everything until the last element of 1,000 come here, right? You got it?
Yeah.
Yeah, right. You see, because whenever you found it, you just exit. Why do we have to run it again and again and again to last element here? So sometimes if you have a huge database, it takes a lot of time. Right? It takes a lot of time working with the search engine. Right? So in order to do that, you can modify this one here. So in the case of this one here, instead of run everything from the first element to the last element, now whenever you matching the file, you exit the loop immediately instead of waiting to the last element. Okay, so that is the way it works, right? So you see, this is zero code for this one, and this is this is a flowchart, and this is zero code here. So for this one, you can see about this one. you have defined the valid number here. That is array. That is array name, and the size here is 6. You have 1, 2, 3, 4, 5, 6 element here. Now you have to change the file width. You have to change the file width here. So you get ready. Once you get ready, get the item here. And why item is not finished? Keep doing the file item here. So we see you have something to do at the beginning. You have to set the index here, number 0 at the beginning. You have to set the flag here, it no at the beginning. Yeah, right. So now you run it, right? Run it everything from the first element until the size here. It's the last element here. Right? So if item equals the valid item, you put the file width. Otherwise, if not, you just increase it here. So we see whatever it is, you only have to run it from the first element to the last element. It doesn't matter. You only have to do it. Right? And when you exit the loop, you have two possibilities here. You found it or not. In the case you found it here, you put the message here. It's item available. If not, you just increase it to the bad item here. Now, okay. Oh, this one is not. This one not yet. Right? This one not yet. Okay, so now we'll looking the parallel array. parallel array, it is a two think about this one. Parallel array, it is array that they have the same size. The first thing here. Parallel array, they have the same size. And each element of the array, they are related together. They are related together. So we can think about example of the main order within it here. You have the two array, each with the 6 element. I see the first, in order to have the parallel array, you must have the same size. So each of them have the 6 element here. They have the same element. I have the same size here. And remember, the first thing they must be on the same size. The second one, each element of each array, they have to be related together. Okay, so you can think about this. You have the two array. It's a 6 element. You have valid item number and you have valid item prices here. Right? So each price in the valid item price price array is the same position at the with the corresponding item with the valid item with the number. I can think about this one. You have item. You have item here. So everything from 0 on over to the 5. And for this one, you have the price. And also you have everything all over from 0 to 5. So if item number 0, you have the price number 0. And if item number 5, you have the price number 5 here. Now see, you have the same size. And each element, they are related together. Now, you can think about this one. You can think about this one here. So on the top, it is item. And on the bottom, it's the price here. So you see, all of them, they have the same size. They have the 6 element. And the item number 0 has a price of 0.59. And the item number 1 108 here has a price of 0.99. They have same size, and each element, they are related together. Okay, so you have a lot of benefit when working array. Normally, we're using the array when 2 or more array contain related data. That's the thing. And index related arrays, element at the same position in each array are logically related here. So we see the relationship with the item number and its price, that they are related together. Okay, so think about this one here, using the parallel, using the parallel array. So for this one, you have the 2 array. Remember, for this one, the parallel, right? You have 2 array for this one here. So all of them, they have the same size. Size here, the number 6 element. And the first array name is the valid item. And the second array name is the valid price here. Right? So for the valid item, you have everything. You have every element here. And for the valid price, you have every element here. Right? So now you're working on the, if you look at the flow chart here, the same and the item number here. So you have the item number. The item number. This one is the item number here. That is a housekeeping, right? So when you check it here, if the item is not finished, keep doing it, right? So in the side of the body, look, you have the 5 item here. So what is the 5 item? 5 item here. In the 5 item, sorry. Now, what is the 5 item? What is the 5 item? Again, remember that in order to working with the searching here, you have 2 things you have to remember. You have to set the flag to the full or no here at the beginning. And you have to set the index is number 0 at the beginning. It is the beginning index here. Right? So we see you have to set the flag here to no, and you set the index here number 0. Now you run it everything from the first index to the last index. That's why you check with the size here. The size here is a number index in the array. And you see? Now, for every time you check the item is a valid item or not, right? Valid item or not, you put it yes. You put it yes, and of course, when it is a valid item, you have the correlated price here. It correlated price here. I think about if you go back to if you go back to this one here, right? So whenever you have the matching item, sorry, whenever you have the matching item 105, you know that its price here is 0.99, right? Because they are matching together. So we see when you found the number 109, you know that this is index number 1. So we just take out the valid price number 1, it's a 0.99. Right? So we see you have a lot of benefit working the parallel already. You start working on the index number, and they are matching and related together by the index number here. So you see, when you found it instantly, you know what is the price here. And you see, you can clearly see that they share the same index here. They share the same index here because they are related together. Huh? It makes sense? Hello?
Yeah.
Okay. Okay, so that is a pseudocode here. Remember, if you look on the pseudocode also, you see you have two parallel array, the same size. And when working the searching here, set the flag is now here. Set at the beginning index 0 and do it here. Do it every time, right? Check if the item valid. And of course, when the item valid, you have the matching price with this one. And they share the same index here. That's all. Now, that is improving search efficiency. That is what I mentioned before. Right? Because basically, if you look on the search up to now, you always have to run it from the first element until the last element here. Right? Even though that you just found the matching at the second element or the first element or the fifth element, you don't care. You only have to run it from the first element to the last element here. Right? So you have to think about how to exit the loop early. So whenever you find someone match, you have to exit the loop here. So think about if you have the large array here, you take a really long time to run everything from the first element to the last element. Now come back to this one. Right? So come back to this one here. So at the beginning, before, you see, before it, you only have the one condition here. That means you run it from the first element until the last element. So see, when the index here is less than the number of the size element, you just keep doing it, even that it match or not. You don't care. You just run it from the first element to the last element here. Right now here, you can modify it here. So in the case of the sub is less than the size and found it number and found it is no here. That means you have not found it. Keep doing it to the next element. Keep doing it to the next element here. But here, let's see here. Whenever you have a found is equal to the yes, you just exit it here. So see, so even that you found it in the element number 2 or 3, you just exit it. You don't have to do it for the next element here. So it has a lot in the processing time here. Right? So we see in that case here, whenever you have the sub less than the size and the file here, no, you keep doing it. But any one of them, right? Any one of them is not correct. So we think about when you run to the last element or when the file is yes here, you just exit the loop here. And of course, in the loop here, you have two possibilities. The first one is that you run everything from the first element to the last element, but you are not, but you did not find it. That's why you put it here, now here, and the bad item equals the bad item. Or in the case that you found it here, you just print now, I found it here. So you see, this way, this program, this searching here, is way better. Because if you think about, if you have a very huge array, you have 1,000 elements or more than 1,000 here, if you're working with the previous search, you have always working from the first element to the last element. But right now, whenever you search matching, you just exit the loop. Got it? Hello? Okay. So we see you use the combination here, right? Because if you remember that when working with selection or loop, in the case if you want to exit loop or the selection here, you can use the combination logic here, right? You can use the combination of the condition here, and you can see Whenever sub less than the size and the pound, no, keep doing it. But any one of them, so in sub equal to size or file equal to yes, user exit the loop here. Now, searching an array for the range back, that one is also very useful when working with the array. Think about this one. Programmer may want to work with the range value in the array from the 1 through 5 or from the 20 to 30. Example, in the mail order business here, you read the customer order data, determine the discount based on the quantity order. So the first approach is that you array many elements at each possible order quantity, store operate the discount for each possible order here quantity. So think about this one here. Think about this one. Think about this one. Here's the discount. So if you have from 0 to 8, you have discount number 0. You have from 0 to from 9 to 12, you have discount number 10, the 10%, and you have from the 13 to 25, you have the 15% discount, and more than 26 or more than you have 20 here. So if you want to store in every element here, you see, you have the number 0. Sorry. You have number 0, number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8 here. You see, from 0 to 8, you have 0 here. Now, from 9 to 12, from 9, 10, 11, 12, you have the 10 here, 0.1, and so on. From the 13 to 55, you put it here, and more than that here, you have the 20 here, and so on. So it works also, but it is increased efficient here. In this color right here. So you see, you have this one. You have drawback here. You have drawback for this one here. It requires a very large array. It requires see, you have to store every element. You have to store every element with the one value, and even that they are the same value here. You see, you have 9 number 0. You have 4 number 0.1, and so on here. They store the same value repeatedly, and how can you know when you have enough elements? So we just think about more than 26 here. How can you know? It can be 100, can be 1,000 here. You have no way to store every element on that way. So with that way, you have the better approach. You have the better approach here. You create the 2 parallel arrays, each with the 4 elements. For this one, you create the 2 parallel, each with the 4 elements. So instead of many elements here, right now you just maintain the 4 elements for each array, and they are parallel array. One array has the 4 discount rate. One array has the 4 discount rate. You have 0, you have 0.1, right? You have 0.15, and you have 0.2 here, right? And the one array has a low end. You see, you have low end of each. You have low end of each quantity range. So for this one here, everything from 0 to 9, you have 9 here, right? And this one, everything from, you have 8 here, right? You have 8 here. And this one, everything from the 9 to 13, you have the 13 here. And this one, everything from, 15, right? And this one is 26 here, right? So we see, you maintain the 2 arrays. The first one is discount rate. You have 0, 0.1, 0.15, and 0.2. And the second one, you have everything from 0 to 8 here. This one, everything from the 9 to 13. And this one, everything from 9 to 12 here. And this one, everything from 13 to 15. And this one, everything from 16 to 25. And this one, what is it? Let me come back to this one. I'm really not sure about this one. Okay, now see. Instead of maintain many elements here, right? And even that, you have to maintain many elements and store the same value, a lot of them. And in the case of 26 or more, it can be 100 or 1,000. You have no idea. That's why you just break it down into the lower end here. Right? See, instead of that, you break it out into 2 parallel arrays. The first, and each of them only the 4 element array. Right? So we see for this one here. you have the discount here. You have 0, 0.1, 0.15, and 0.12. And for this one here, low end here, low end here, you have 0 here, and low end here, you have 9 here, and you have no low end here, you have 13, and this one you have low end here, you have 26 here. Right now, you just understand that you have to work in the parallel, right? And you have to maintain the quantity limit based on the low end of each rate here. So how it work? See how it work here. Now see it here. So now you just do the housekeeping, body loop, and to finish here. So what is housekeeping? Housekeeping and input the quantity here. So it depends. It depends on the number of quantity. You can take the decision. What is the percentage of discount here? So now think about this one. When the quantity not great, keep doing it is a determine the discount here. So what is the minute count? Remember about this one. In the minute count here, you always have to work in from the higher range first. So you can think about this one here. You have the range of value here. You have 0, you have 9, you have 13, and you have 26 here, right? Is it correct or not? Let me come back. You have 0, you have 9, 13, and 26. Okay. Now remember, when working with this one here, you always have starting from the highest number first. From the highest number first, right? So the first thing here, you check the condition. If it greater, sorry. The first thing here, you have to check the condition. If it's greater than 26 or not. If greater than 26, you just put it here 0.2. If not greater than 26, you check it again. If greater than 30 or not, and of course, if greater than 13, it is the range from the 13 to the 25 week. So in that case, you put 0.15 here. Now, if not greater than 13, you can check it greater than 9 or not. Greater than 9 or not. So everything from 9 to this one, you put 0.1. And of course, the last one, you have nothing here. So in the case here, remember, that is very important here. That's very important. You have to remember when working on this way, you always starting from the highest number first. You always starting from the highest number here. So we see here. That's why you working from the highest number. You're working from the last element for this one, because you see you have for this array here you have 0, you have 9, you have 13, and 26. This one is the highest number, and this one is the last element. That's why you're starting from x equal to psi -1 here, because the reason you have the -1 because actually the index number working from 0. That's why it is always from 0 to the last element. It is the size -1 here. So you see, you're starting for this one. Actually, you're starting with the 4 here. Now is the 4. So see, if quantity less than quantity limit of 4, that means less than 26 here. It's a lot less than 26 here. So if you less than 26 here, you -1. That means you move back to the check with the 13 here. You move back to change the 13. But if if no here, that means it's greater than 26. So we see you just instantly print out the discount here to 0.2. And think about this one here. Now to make it simple, to make it this one here. Now, what happens if you enter the number 10 here? See, if the user enters the number 10, you check this one. Check from the last one here. Number 4, check 10 here. If 10 less than 26, yes, right? So you -1. That means you now check with the index number 3. This one here. This one starting is the number 3, and now it's starting with the number 2, right? So now we check with number 2. Now 10 here less than number 13, right? You check again, less than 1. So now we check the number 1. 1 is here. 10 here, greater than 9 or not? Yes. You just print now here. Right now it's 0.1. That's all. Too much. Okay. It makes sense or not? Let me know. Let me come back it again. I think this one is makes it better here. Remember that for this one, you have the range value here 0, you have 9, you have 13, and you have 26 here. Right? And of course, this one element number 0, this one element number 1, number 2, and number 3 here. And you have the 4. The side here is the 4. Right? So think about this one. User enters the 10 quantity. Now think about this one, 10 quantity. If starting x equal to side number 4 minus 1, so we're starting with the number 3 here. Starting with the index number 3, because you want to working with the highest number first. Right, so see, the quantity here less than quantity limits of 3 is a 26 here, right? You see, it yes. Right, so with now x equal to x minus 1, so now x change it to 2. Right? So when you check it to 2, again check if 10 less than quantity limit of 2, what's the 2? 13. Yes, you minus x, now x is 1. I check it again. Now if the 10 less than quantity limit of 1, 9, not correct, right? So when it's not correct, use that. No, for sure, this one is this one for sure, this one is 0.1 discount here. That's all. That is the way working on this way. You're working on the range here. It makes sense? Let me know.
Yeah, a little bit. Yeah.
Sorry?
Yeah, a little bit. Yeah.
Okay. So that's the way you work. Let me give you another example here. Again, you have to remember that you have the range here. 0, you have 9, you have 13, and you have 26 here. Index 0, 1, 2, 3, the side number 4. The starting from the index, highest index here, number 26 here. Starting with 3. Now think about this one. If the user enter the input, the quantity is 15 here. Again, you check 15 less than quantity of x, less than 3 here, we got 15 less than 36. Right? So yes, less than x reduce 1, so we have 2 here. Now check again. If 15 here less than quantity limit 2, no, right? No, 15 greater than, so we see for sure this one here is the 150 here. That's all, 0.50. Right? That is the working range here. It's a way benefit here. You don't have to store every element here. You just store the end limit of every range here only. And remember that in order to do that, you always starting from the highest number first. From the highest number first. Now, in the homework, when working with when you sort order here, in the homework you see that you have to arrange you have to sort order with the grade and the grade character here. So think about if you have 90 or greater than 90, you have A. You have greater than 80, you have B. You have greater than 70, you have C. Greater than 60, you have D, and less than 60, you have less than 60, you have fail here. So for this one here, remember, this one is the highest number for this one. The highest number is 90 here, right? So this one, you cannot starting from the last element, but actually for this one, you have starting from the first element here. Remember that? Yes, starting from the number 0 here. Now we check if the quantity less than number 0. Yes, we deal with greater than 80 or not, we deal with greater than 70 or not, but not less than 90, you know that is greater than 90, so you instantly have the idea. Right? So the process of this one, you have to understand that you only have to working from the highest number first. So if it's in the order from the smallest to the highest, you have to working on the last element. But if you sort in the order from the highest to the smallest here, you have to work in the first element. Make sense? Okay. Okay, so here's the working with the pseudocode. Okay, now remaining with the array bounds. Every array has a finite size. Remember that we have a finite size, and that is the number of elements in the array. It's the number of elements in the array, and the number of bytes in the array. So And array are composed of elements of the same data type. You have to know that. An element of the same data type occurs the same number of bytes in the memory, and the number of bytes in the array is always multiplied by the number of array elements. And access data using the index number here. Right? And what is it? Inbound. Inbound, that means that the index in the within the acceptable range, that means from 0 to the last element here. Right? Outbound, that means when we accept it out of the index range here. Okay, of course, in the case that you accept the outbound index, normally you have the syntax error. You cannot do it. Okay, to improve program, add the tag to make sure that the enter submission is valid or not. I think about this one here. Think about you ask user to enter the month. So basically, you know that for the month you only have the size 12 here. So you have to make sure that you have to validate that index here is everything is range from 0 to 11. That's the thing you also working. So if the enters index is not valid, normally you have to display the error message. I think about out of range or something like that. Use a default value or reprompt the user a new value until it's valid or not. Now using a for loop. Using a for loop to process the array. So the same, right? So in working the for loop in the single statement here, you only have to initialize the loop control variable and compare it to the limit and alter it. You have the three things here. You working the for, initialize. So think about you setting the index number 0, right? Now, and you compare it is less than the size or not. If it's less than the size, keep doing it, and of course you have action to alter it. That means after that you increase the counter to number 1 here, counter plus 1 here, and of course for the for you have, as I mentioned you on at the beginning of the class here, you can use the 1 argument. You can use the 2 arguments, or you can use the 3 argument here. Yeah, so we see for this one here, right? So for this index, for this array, you have the, what is it? We have depth department, right? Department here, you have the size 5 element, right? So we see when you're working with the loop, when working the for here, you have initialize the value, right? And you check if the value here less than the sign -1, keep doing it, and you have always the action to alter it here, to change it here. That means increase by 1. Remember that if you are missing this one, you have the infinite loop here. It will again and again forever. Okay. What is it? What is the difference here? Okay, so I think that's all for the lecture for today. Any question? Any question? Any question? Please let me know. Hello? Okay, so if you don't have any question, I'll see you guys on Tuesday. And remember that for any homework, I strongly recommend you to do with the home. And if you have any challenge, come back to me on the class on the Tuesday here. So on Tuesday, I will correct any homework if you want, and I will continue with the chapter 6 here. Okay, bye guys. Bye bye. Have a good night. Bye.